Jai Sri Krishna. Hello friends, a very good evening and welcome to IT Club. I am Prosenjit Kunti. Today we are going to learn about the much interesting, conceptual and demanding topic Kubernetes. In this session, I am sharing Kubernetes concept in briefly. So I can assure you after watching the whole video, you will be have a good knowledge about Kubernetes. About Kubernetes. Let's see what topic I am going to discuss today. What is Kubernetes and how does Kubernetes works? What is the control plane or master node and what is the worker node, its component, what is API server, scheduler, etcd, kubelet, kubeproxy, and what is container runtime, what is pod, Kubernetes features, and Kubernetes pod autoscaling, horizontal and vertical, and clustering. Frequently asked question in certification, CKA, CKAD, and CKAs, like that exam time, passing the mask, and what are the ID requirement, how do I renew my certification, like this. Also cover Kubernetes case study with Domino's, Boss, eBay, or so many renowned companies like banking sector. And lastly, we can discuss tips and tricks. Okay, so let's start. Okay, what is Kubernetes? Kubernetes is an open source software which provides a platform to build the applications code, to deploy the applications, to scale the applications, to monitor and manage the applications on the Kubernetes. I repeat, Kubernetes is portable, extensible, open source, containerized workstation, containerized workstation platform. We run containerized application on top of the Kubernetes cluster. The Kubernetes what's coming from Greek. That is the originated from Greek. That means Helmets or pilot. That means the pilot. And Kubernetes an abbreviation result of counting of 8 letters between K and S. In Kubernetes, you can see in between K and S there is a 8 digit is available, so that it's called as K8S. That is K8S. It is basically a product of Linux Foundation. The Linux Foundation product. Yeah, try to understand this. Try to understand this. We have a three deployment model over here. One is the traditional deployment, and second one is the virtualization deployment, and third one the container deployment. The container deployment. This is how evolution happens. In earlier in earlier days, we used to have only traditional deployment, where in we have the physical server. We used to install operating system on top of it, on top of it, and then we used to install applications. If I want to have a dedicated database server, then I had to have a physical server. If I want to have a dedicated web server, that time also I used to have a dedicated physical server. For that, for that, so more number of application I want to run in the dedicated or isolated environment. So used to more number of physical server. Need to be more number of physical server. So investment was high, and not only investment but also maintenance, monitoring, recurring cost, everything is there. So we can say it is to drawback. It is the drawback over there, or there is a limitation. There is a limitation. Virtualization deployment. Later on, we move to the virtualization deployment process, wherein we can have a single hardware, top up it operating system, and then we can install the virtualization software. You can you all like the VMware. In virtualization, we have special component have called hypervisor. In virtualization, we have a special component here called as called as hypervisor. Using this hypervisor, I can install multiple operating system on top of the same physical hardware. Same physical hardware. That is called virtualization. Virtualization in the process of running multiple operating system on the same physical host. In this diagram, we have a two virtual machine. We have a two virtual machine. There is a virtual machine 1 and virtual machine 2. And remember, every virtual machine complete operating system. Every virtual machine means complete operating system. It's just like a physical server. It's just like a physical server, because here we are installing complete operating system, kernel, then top of it applications. But the advantage is the applications are isolated. The applications are isolated. Application which is running in virtual machine and application which is running this virtual machine is completely isolated. It's completely isolated. Virtual machine is not lightweight. We can say it's not lightweight. It's rather than heavy weight, because it's just like a physical server. So only thing is, by using virtualization we can do optimum utilization of hardware, because all VMs will be sharing the same hardware of the base system. So container deployment. Okay. So now we are in the age of containerized deployment. Now, what is the container? What is the container? A container is a complete deployment unit. A container is a complete deployment unit which has the application along with the dependencies. What are the dependencies? Like the library files, binary files, configuration files, and runtime environment, which are required to run the applications. So who is going to create the container? That is container runtime. That is container runtime. First, physical server, then top of it operating system. The same way the virtual machine. This up to this, the same virtual machine and container. Up to this, the same. In containerized deployment, first physical server, then top of it operating system, then top of it need to be installed a container runtime. There are couple of container runtime available in the market. We have a container D, we have a cryo, we have a rocket, and that means rkt, we have a docker, but but in Kubernetes does not support now in docker in going forward the that runtime actual environment run the container. So today, if I say there are three container running. What is the difference between virtual machine and container? What is the difference between virtual machine and container? In virtual machine, also the applications are getting isolated. In container, also applications are isolated. Okay. In virtual machine, applications are isolated. In container, also applications are isolated. So what are the basic difference? In absolutely, but container is absolutely lightweight. Container is using container, we can lead to microservices, because in cloud we need lightweight component. We cannot run heavyweight component. It will be slow. Now question is why it is lightweight? We have a only only application, maybe a Python or maybe a PHP, or it may be web application, and their dependencies like binary file, library files. So container does not have any operating system. Container does not have any operating system. It does not have any kernel, and that has becomes container very lightweight. So container does not have any operating system, it does not have any kernel, and that has become container is lightweight. All container will be sharing the same operating system of the container host. The container host. So here I have already created a PDF. Here I have already created this PDF. You can see, and I'm going to discuss today in this PDF. If anyone interested, or if anyone wants to take this PDF, then write to this video comment. Just write, please share me the PDF with your mail ID, so I can mail you one to one. Okay. Okay. Now see the how does Kubernetes work? How does Kubernetes work? In Kubernetes, there is a master node and multiple worker nodes. Each worker node can handle multiple pods. So that is the Kubernetes architecture. There is a master node, and this is a worker node 1 and worker node 2. So let's discuss about from the master node, also known as control plane. The master node manage the Kubernetes cluster and its entry point, the all administrative tasks. You can talk to master node via CLI or user interface. You can talk to the master node in both the way. When we have a more than one master node, actually in production environment, there is a multiple master node. Then would be high availability mode, and with one leader performing all the operation, and all the others master node on the other master node would be the followers of the leader master node. Kubernetes concept just like a master slave type architecture, just like a master slave type architecture. Okay. Um, Total phone number component have the master node. In master node, API server, scheduler, controller manager, and etcd. Well, phone number component have in control plane. So let would we discuss one by one. Okay. So first, I will discuss about what is the pod. What is the pod? The pod is basic component unit in the Kubernetes. What is the basic component unit in the Kubernetes? Means whatever I want to deploy a containerized application, the application is deployed as a Kubernetes resource. That is what is called pod. Kubernetes does not understand container. Kubernetes only understand the pod. A pod may contain a single container or the multiple container. A pod contains a single container or the multiple container. Okay, let's discuss the API server. What is API server? Application Programming Interface. API is a gateway. API is a gateway Kubernetes cluster. Why? Because whatever we want to create any resource, we have a post the request to the control plane or master node in the control plane. If it is the posted the application or API server means API server front end component. API server is the front end component for the Kubernetes master node. So that in one line say API server is the front end component in control plane. So what is the etcd? etcd is the distributed key value database which contain container cluster state information. Means whatever resource are created within Kubernetes, all information is stored inside the etcd. Means all about information in store the etcd. Scheduler. Uh, Suppose I said a containerized workload run on the worker node, but but you have a two worker node, one worker node 1 and worker node 2. You have a two worker node here. If I want to create a pod, who is going to be responsible or decided the pod will be created on worker node 1 or worker node 2? It is the cube scheduler or scheduler to decide or to maintain which pod to be deploying the pod, that is for scheduler. So scheduler is on of the control plane component that watch for all newly created pods with number assigned nodes and select a nodes for a for them to run on. And controller manager. Controller manager. The name itself understood the what it does. Controller manager is a component of the control plane running in the form of a container with a pod on every master node. A control a controller manager responsible for managing variance controller that ensure the decided state cluster in the maintenance. By keeping this responsibility, it is ensure or maintain, upgrade each each component independently. Each component independently. Okay, and now discuss about uh, worker node has three components. One is kubelet, kubeproxy, and container runtime. Container runtime. So first discuss about kubelet. Kubelet is nothing but an agent which runs on each node in the cluster. Means worker node as well as also be run master node. It ensures that containers are running inside the pod. Basically, basically, Kubelet is responsible to pulling the container image from the container registry. Kubeproxy. Kubeproxy is a network proxy that runs on each node in the cluster. Means worker node and control panel, both the nodes resides. Kubeproxy. Okay. So after creating pods, Kubeproxy maintain network rules on nodes. These network rules allow network communication to your pods from network session inside or outside the cluster. Inside or outside the cluster. Now, what is the runtime? Container runtime. Here, I am using container runtime as a container D. So already I have discussed so many container runtime is available in the market, just like a container D, Docker, is Cryo and Rocket, etc. So container runtime is a basically used to run and manage the container lifecycle on the worker node. So on the worker node. Okay. So let's see with a diagram. Let's see with a diagram and the better way, the practical diagram. Okay. Now I'm explaining a very simple or real practical example. How does work the Kubernetes architecture? How does work the Kubernetes architecture? So how a pod create actually? First, a pod creation request provided by admin in master node by using command line interface, UCL or user interface. So request going to fast fire. The request going to fast fire the API server. The API server because the API server the front end of the master node, because this is the master node and this is the worker node. Then the API server check with queue scheduler check with scheduler. Because of that, scheduler select which worker node will be deploying the pod. Okay, but scheduler does not have any information about the pod like hardware specification. So then then the HCD comes in the picture. Then the HCD comes in the picture, so that scheduler reach out to HCD from the from collecting the information in the pod. After getting the pod information, scheduler select a best performance worker node to deploy it. Now coming in the picture worker node. Now coming in the picture in the worker node. Once Kubelet getting all the information from the master node, then Kubelet communicate the container runtime and container runtime and now installing the container image or creating the pod. Controller manager. Controller manager always responsible to maintain the desired state of cluster should have maintained. So in say the better way, just like a that's मान लो कि ये एक ऑफिस है, ये ऑफिस में जो एपीआई सर्वर है उसको हम एज ए रिसेप्शनिस्ट डिनोट कर रहे हैं, और जो शेड्यूलर है उसे हम प्लानिंग टीम, और जो एचसीडी है उसे हम एचआर बोल रहे हैं। तो इसीलिए इजीली इसको समझने के लिए मैंने डायग्राम बनाया। जो पॉड है वो मान लो कि जो इंटरव्यू देने के लिए बाहर से कोई आ रहा है, तो जो भी कोई बाहर से आएगा नया ऑफिस में, जो सबसे पहले कहाँ आएगा, जो रिसेप्शनिस्ट है उसके पास आएगा। उसके बाद वो रिसेप्शनिस्ट चेक करेगा हाँ प्लानिंग टीम से कि ये पॉड के लिए कोई स्लॉट खाली है कि नहीं, कोई प्लानिंग है कि नहीं, कोई इसके लिए कोई इंटरव्यू स्लॉट बुकिंग है कि नहीं। बट शेड्यूलर चेक करेगा कहाँ से, एचआर टीम से, कि जो पॉड आ रहा है उसका इंफॉर्मेशन ओनली फॉर एचआर टीम के पास रहेगा, जो इंटरव्यू आ रहा है कैंडिडेट की इंफॉर्मेशन। तो वहां से कलेक्ट करने के बाद ये शेड्यूलर क्या करते हैं, एक एल्गोरिथम क्रिएट करते हैं, और बेस्ड ऑन द एल्गोरिथम से नोड को सिलेक्ट करते हैं व्हिच नोड शुड बी इंस्टॉल। सो पॉड को सीधा पुश कर देते हैं कहाँ, वर्कर नोड की तरफ। देन वर्कर नोड में जो क्यूबलेट है, वो क्यूबलेट कंटेनर रन टाइम के साथ कंबाइंड होके जो रजिस्ट्री फाइल है लाइक nginx और http, तो उसको डाउनलोड करके पर एक पॉड बना देते हैं। तो दैट इज द होल सिनेरियो, दैट इज द होल सिनेरियो। Okay, so we can discuss here uh, some key features. Now we can discuss some key features and Kubernetes that make it unique. Okay. Some automatic bin picking. Automatic bin picking. This is where Kubernetes help in automatically placing containers based on their resource requirement limits without compromising on the availability. Service di- Service discovery and load balancing. Service discovery and load balancing. In simple words, service discovery is the process of figuring out how it connects to the service. Self-healing. The self-healing. So restarts the containers that fail, replace and reschedule containers when nodes die. Automated rollback and automatic rollout and rollbacks. With these features, Kubernetes does progressively roll out changes, and it ensures it does not kill all your instances at the same time. At the same time, the secret and configuration management. Secret and the configuration management. So Kubernetes has a built-in mechanism of storing configuration values that you would prefer to the keep private sensitive information such as a name, password with encryption and other credential can be kept confidentially. Can be kept confidentially. The lastly storage orchestration. Automatically mount the storage system of your choice. Whatever from the local storage, a public cloud provider such as a GCP, the Google Cloud Platform, and AWS, the Amazon Web Service, and also network storage systems such as a NFS or Claystar or Frostar, etc. Okay, so let's discuss about here we can top practice. Here we are the top practice of the Kubernetes. Kubernetes help a very easy automation for container lifecycle management. Kubernetes helps in very easy automation container lifecycle management. However, its concept of the container it's quite complex. It's quite complex. The list of the practice, the disallow the root user, disallow the privilege container, user pod resource limit and the requester, and disallow the new capabilities addition, disallow any changes, disallow any using being mounted. Okay, use read only root file system, disallow dock socket, and disallow uses, and keep smaller base image. Okay, so Kubernetes core features. Let's see the Kubernetes core features. That is the Kubernetes core features. How nicely make this diagram with orbital concept and container runtime. Container runtime. Kubernetes use container runtime interface, a CRI, and trans to transparently manage your container without necessarily having the know the runtime uses. The network plugin, a, a certain orchestration, a certain orchestration system is responsible for the managing the network through which consistent or service communicate. The volume plugin, okay, a volume plugin the broadly refer the storage that will be available for the pod. The image registry, it is a image registry. Kubernetes must contain an image registry to be the able full to be the able pull image from the registry, and that should be do with Kubelet. Cloud provider. Kubernetes can be deployed on almost any platform you may think of. And lastly, the identity provider. Identity provider. You can use your own identity provider system to authenticate your own users to the cluster as long as it user OpenID concept. The OpenID concept. Okay. Now, now Kubernetes setups. How much time can you devote the setting of the Kubernetes? That is up to you. That is up to you. The answer is that is the question asked for yourself because of installing the setting of the Kubernetes cluster can be doubting is yes. Okay. So Kubernetes auto scaling that is the good features. Kubernetes for auto scaling. How does it works? Okay. Um, so there are three types of scaling availability, and one is the horizontal pod auto scaling, and vertical pod auto scaling, and last one is the cluster auto scaling. So here I will be discussing one by one. So first of all, the scaling, horizontal scaling. So about horizontal scaling, it is all about scale out and scale in. It is allowed scale out and scale in. Let me discuss. Just think about the 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 Flipkart or Amazon company. In BAU days or business as usual day, they got for example 3,000 or 4,000 requests. But during the load or during the sale or BBD Big Billion Day, probably the Flipkart server will be receiving an 80,000 or 90,000 requests in per hour. So that if the workload is huge, then it's very difficult to manage the traffic without increasing the resource. So horizontal scaling is always monitoring the workload, and the movement of workload will be higher. Suppose in BBT time or Big Billion Day in Flipkart or sale time, then automatically the new pod should be launched. The new pod should be launched. That is called scale out. That is called scale out. Okay, so that is called scale out. When the pod is increases, that is called scale out. In after that, in BAU time start or the load down or the scale is over, that time also the request come from lesser than BBT time, so that that time the pod can be decreases. It's called the in scale in. So just think about Flickr in the BAU session and the big billion day. So there is a one board, the one CPU, 8 GB of RAM, and what 1 TB of hard disk and SSD hard disk. And in load time and sale time, there is a 3 CPU and there is a 24 GB of RAM and hard disk also with 3 TB. So that is called scale out. In vertical scaling, that is all about improve or replace the existing server. That is all about the hardware capability. It is all about the hardware capability. Suppose uh, suppose uh, it all about install type in hardware dependencies, and I have a server. Okay, suppose I have a server that one CPU, 8 GB or RAM, and 1 TB in SSD. But I want to upgrade my server and dual core CPU, 16 GB of RAM, and 3 TB of hard disk. That is called vertical. That is called vertical pod autoscaling. That is called vertical pod autoscaling. When increase the hardware, when increase the hardware, that is called scale up. That is called scale up. When increase the hardware, that is called scale up. And when decrease the hardware, that is called scale down. But it's not recommended. But it's not recommended. Now, cluster autoscaling. Okay, so cluster autoscaling request note. Actually, how nicely shown the diagram. The pods are pending state. Some due to not having enough available cluster resource to meet their request. So Kubernetes detect the new pods once it's provisioned by the underlying infrastructure like GCP or AWS. So Kubernetes scheduler Kubernetes scheduler ठीक है, Kubernetes CDR allocated the pending pods as a new pods, as a new pod. Okay, and lastly, go back again and check there is a still pending pod available or not. So that is called cluster auto scaling. That is called cluster auto scaling. Okay. Okay. Now let's discuss about the certification. So first of all, the CKA, certification of Kubernetes administrator, and the CKS, the certification Kubernetes security specialist, and CKAD, the certificated Kubernetes application development. There are three types of certification available. So there is a most common question: how long will the exam take? It is 2 hours. All the certification in CKA, CKAD, or CKS. What score is needed to the pass marks? In CKA on CKAD, both are the 66%, and CKS and 1% is higher, 67% needed to earn the pass marks. So how is my exam score? So around 14, around 24 hours from the time the exam was completed, you will get your result. You will get your result. So what are the ID requirement to take the exam? And normally in the international travel transport travel passport, the government issue driver license, or the government issues the ID card, the photo and signature will be there. What language is exam offering? There is a three language, the English and the Chinese and Japanese. And how do I renew my certification? In CKA or CKAD, there is a 3 years. And in CKS, it is only 2 years effective from the date of examination passed. Okay, the main question is how much does certification cost? Both the exam, all the exam, CKA, CK and CKS, all the exam cost fee uh, $395 each, only for exam, only for exam fees. Okay. Also you can hear the over the Google, just go to the kubernetes.io docs and search for, just write it down, the exam exam fee. So that is redirect to training and exam. Okay, and go down. There is a CKAD or CK or CKS. Also be uh, also be cloud native to certification available there. So CKAD in CKA, in CKA in 395 only the exam fees. If you need the course with exam, if you need a course with exam, that is the 595. But in time to time, very in time to time, it's to offer is going on, just like a gift on learning with 30% saving in December 21st. So every time there is a going on in discount, you can just following up in any certification any certification, CKAD, CKA or CKS in 395, all the exam fees, and course fee with course fee 595. Only the cloud native to cloud native certification are available. Cloud native in exam fees is too less in 250 only, $250, and both the exam fees $250. Yes, it's a $250. You just go to the kubernetes.io. That is the official page in Kubernetes. Okay. Uh, Now check with quickly Kubernetes case studies. Delivering pizza with Kubernetes. Domino's cloud native story in mind blowing. In Domino's, pizza can release without driver or driverless car to the deliver the pizza. In 50 years old company, the Bose also mold use in Kubernetes, and there is a banking sector. In the previous time, there is a banking sector in the rail server, over the rail server top of the service 1 2 3 4 and n number service that can be used. That is the high cost effective, and now today's world is mold in Kubernetes, and there is a node concept, and so many microwave service are running in a cloud native, and eBay digital also be transferred, and Sufficy there is be available. Okay, so I have shared also the interesting cloud native trends by CNFC survey. So you just go through the PDF. So once again, I'll share you. So if you want this PDF, just ping me my video comment box with your mail ID so that I can mail you one to one with the attached PDF. Okay, Kubernetes tips and tricks. You just go through this. Best complete the mykubectl command for me. Add default memory limit, CPU limit, namespace, and Kubernetes can you please check my Docker image. So Docker image is also not supported right now. Kubernetes is used in container D. Okay, take a look at this 10 Kubernetes production checklist. So provision, deploy, installation, configuration, security, monitoring, performance logging, backup and restore, and networking, cost effect optimization, documentation, and etc. So that okay, and that is the PDF file. Okay, now I am sharing with you the GCP practical. There is a I have already ready with my cluster. There is a GCP platform, Google Cloud platform. There is a total three machines are available, and master, the master node, and worker node 1 and worker node 2. All three are spinned up, and there is also machine available in CentOS orchestration, but there is a difference. I can use my different project work in here. So I will share you just using the SSH. I can share you. Okay. Okay, so, minus I. Let's see the OS. Okay, here I am using Ubuntu operating system, and the version is 20.04. Because of that, all CKA exam or CKAD exam now held on Ubuntu operating system. That's why I'm using CKA, and I will be sharing my next video with how to spin up a cluster or three node cluster. One is master node and another two is uh, worker node. Just see qctl command, qctl get pods. Okay, there is no pods are available. Okay. How many nodes are this? Qctl get nodes. There are three nodes. One is the master node, and on the node 1 and node 2 is the worker node. So all are the ready state. Okay. Thank you friends. Bye bye. Today is over.